зараз одну хвилину. Ми можемо розпочинати наш сьогоднішній вебінар, який торкатиметься саме біомаси тепла. І перед початком вебінару і анонсу програми я все ж таки хотіла б звернути на деякі технічні питання. Вони будуть торкатися можливості перекладу. У нас на платформі сьогодні будуть працювати англомовні спікери, тому прошу вас звертати увагу на можливості перекладу з англійської на українську і також на режим роботи чату. Всі запитання прошу поблоково задавати спікерам в чаті. Якщо бажаєте, то є можливість також режиму піднятої руки. І я перед початком хочу вас ознайомити із програмою заходу. Він триватиме 1,5 години. І вебінар називається «Виробництво тепла та когенерація з біомаси для систем централізованого теплопостачання». Тобто ми будемо говорити з одного боку про технології, з іншого боку в нас останній блок буде торкатися саме питання фінансування. Звертаю вашу увагу, що 11 березня буде продовження циклу вебінару, який ми проводимо разом із Датською радою з питань централізованого теплопостачання, і він буде саме торкатися когенераційних установок. Я знаю, що досить багато питань у нас було і запитань від громад під час нашого вебінару з Міністерством розвитку громад і територій, і анонс і програму вебінару 11 числа ви отримаєте протягом наступних 2 днів, тому реєструємося і саме от якраз досвід і комбінація української практики завдяки Датській раді з питань централізованого теплопостачання, можливо, надасть вам відповіді на ті запитання, які ви зараз маєте з урахуванням енергетичної кризи, з урахуванням посилення напрямки нашої енергетичної безпеки. Ми, як проект «Угода мерів Схід», є партнерами зазначених заходів, і гадаємо, що наш з вами такий діалог в онлайн-площині переросте в щось трошки більше на рівні проєктів. Сьогодні у нас з вами буде вітальне слово, до якого ми зараз перейдемо. Перше питання, яке нам розкриє пан Ларс Гулєєв, буде торкатися біомаси в централізованому теплопостачанні як частина зеленого переходу. І тут ми будемо говорити про технології, комбінацію технологій і от якраз про котли і ТЕЦ. Більш детально розкриє нам питання про котли на біомасі, їх загалом технічні характеристики, експлуатаційні можливості. І частково буде питання також когенерації. Це буде Ларс Юстенс, старший експерт компанії «Енергетика». І, мабуть, останній блок, який зацікавить більшість громад, це можливості фінансування. От про фінансові механізми ми поговоримо з фінансовим директором експертно-інвестиційного фонду Данії Коре Стамером Андерсеном. Наразі це все. Є блок запитання та обговорення, але я вам рекомендую, коли ви фіксуєте запитання, все ж таки його зазначати в чаті, щоб ми сумували, підсумовували, і наприкінці ми з вами прийшли запитання блоку відповідей. Я зараз хочу перейти до вітального слова. У нас є Максим Верещак, як ключовий експерт угоди мерів, і є пані Леся Логвиненко. Дякую вам, пані Леся, за те, що ви скоординували і наших датських колег, і скоординували загалом нас як проект до підготовки цього вебінару. Тому, пане Максиме, вам 2 слова, пані Лесі, я даю цілих 5 слів як вступного слова. Дякую.
Дякую, Оксана. Ну, я тоді коротко, ти, в принципі, більшості те, що я хотів сказати, сказав. Це не перший наш захід з спільною з Датською радою теплопостачання, неурядової організації в Данії. Перший вебінар, до речі, був дуже практичний і можемо похвалитися те, що він навіть дав практичні результати. Можливо, пані Леся про це скаже пару слів, але декілька громад уже далі рухаються не просто з теоретичними знаннями, а вже з імплементації та фінансування конкретних проєктів. Тому ми вдячні цій розпочатій співпраці і сподіваємося в майбутньому. Ну і я думаю, цей вибір про співпрацю не випадковий, бо ми часто говоримо з колегами, з вами, з представниками міст, з теплоенерго. І от багато якраз зазначає, що умовно, якщо ви хочете щось побачити по енергоефективності, їдьте в Німеччину. Якщо щось хочете по транспорту, їдьте в Голландію. Але якщо хочете по теплопостачанню, то їдьте саме в Данію, бо дійсно Данія має один із найпередовіших досвід не тільки, так би мовити, в Європі, а й, певно, є одним із лідерів в світі. Тому дякуємо пані Лесі і всі організації, і якби народу Данії, хто якби до цього теж причетний за таку можливість. А учасникам якраз бажаю сьогодні плідної співпраці і не тільки ознайомитись з певними технічними аспектами використання біомаси в центральному теплопостачанні, але тими фінансовими можливостями, якими володіє Данський експортно-імпортний банк, і тими продуктами, якими він може допомогти зараз українським громадам в розвитку теплопостачання. Пані Леся, слово вам.
Доброго дня, дякую за вступ. Я думаю, завжди, знаєте, бути третьою після вступу – це коли вже всі все сказали, що треба додати. Так, ми є асоціація в Данії, і асоціація, яка об'єднує виробників технологій теплопостачання для сектору теплопостачання та так звані компанії, які виробляють тепло в Данії, і разом із також входять в асоціацію консалтингові компанії. Тобто ми є, скажімо, такою асоціацією, яка знає, як робиться, і має можливість координувати організацію таких проєктів там, де є передача цих знань. Насправді ми з угодою мерів працюємо дуже плідно, ми задоволені дуже співпрацею, дуже гарний партнер. Дякую вам за організацію і за те, що ви прийняли участь в цьому вебінарі, організували його так. І ми зі свого боку багато чуємо питань саме по технологіях, по біомасі, і бачимо, що є необхідність в тому, щоб зробити саме не тільки, скажімо, економіку питання розкрити, а саме технічну частину питання розкрити. Тому в нас є сьогодні експерти, які зроблять гарну презентацію на цю тему. Так, будемо модерувати питання з чату, будь ласка, їх задавайте по ходу презентації, всі питання в кінці вебінару, я думаю, ми озвучимо і отримаємо відповіді. Також, що хотіла ще зазначити, що з багатьма з теплокомуненерго ми співпрацюємо на щоденній основі. Ми, як DBDH, Danish Board of District Heating, і кожного року ми організовуємо поїздки делегації в Данію трьохднівні, там, де ми показуємо саме, як організована система з теплопостачання, як вона працює. Ну, це дуже цікавий досвід. Наступна поїздка буде у нас в березні, ми робимо це разом з посольством. Так, і також ми працюємо більш із, скажімо, з тими містами, де ми бачимо саме вже таку готовність для впровадження комплексних проєктів з модернізації. От наразі тут є представники Миколаєва, ми з Миколаєвом працюємо, тому що ви знаєте, що Миколаївська область, вона під егідою Данії. Але ми також відкриті до співпраці, тому, будь ласка, пишіть, дзвоніть, будемо раді координувати, щось робити разом. Я думаю, що на цьому я закінчу свої 5 слів і надам слово наступному нашому спікеру, який відкриє, скажімо так, уже технічну частину цього вебінару, економічну частину. Це Ларс Гулів, експерт з теплопостачання в Данії, який дуже багато років був керівником однієї з найбільшої компаній з теплопостачання, компанії Векс. Тому, будь ласка, Ларс.
Thank you very much. I have a small challenge. I can't see how I can upload my presentation.
Так, хвилинку тоді. Окей, Lars, just a second.
Yeah.
Just now everything is well with demonstration of screen demonstration. Якщо у вас є презентація, можливо, ну, тобто я дивлюся, доступ є, от демонстрація екрану для учасника.
Буквально хвилинку, я тоді її зараз відкрию зі своєї сторони. Зараз. Так. Зараз я спробую це зробити. Вибачте, будь ласка, така в нас замінка вийшла. Так, хвилинку. Як видно?
Бачимо, але перейдіть в повноекранний режим і заберіть, якщо можна, вікно, бо ми себе бачимо.
Yeah. Okay.
Пані Лесю, з центру скріна цей приберіть. Передвиньте його в куточок.
Бачу.
Угу. Все, дякую.
It looks fine now.
Yes, Lars, go ahead, please.
Yes, please. It seems that you have to change the slides, okay? Because it's not my screen. Yeah. Okay, so if we take the next slide, please. Yeah. It's important when we talk about biomass that we know that at least in Denmark, biomass covers a huge group of different products. So next slide, please. When we talk about biomass, it's the organic material from plants where you can see instantly have the fixation of carbon. When we talk about fossil fuels, of course, they also consist of carbon, but it's carbon which have been carbon which have been built up in the materials like oil and gas and coal for many years ago. When we talk about solid biomass, it's in the form of firewood. It's also wood chips, wood pellets, and energy willow, which I will come back to later in this presentation. Then we have straw from the agriculture culture in Denmark. We have also the biodegradable waste in the organic material in waste from households. We talk about liquid biomass in the form of biodiesel, bioethanol, and bio-oils, which can be made from different kinds of crops, such as straw and rapeseed. And then we have the last fraction of biomass is the biogas, which we produced based on manure from cows and pigs in the agriculture sector and other organic residual materials. Next, please. Yeah. To give you an impression of the consumption of biomass in Denmark, I will give you a few slides. So next, please. The consumption of biomass for energy in Denmark is shown on this figure, and you can see during the last 20 or 35 years, we have increased the consumption with a factor of 5, from 40 to 200 petajoule per year. We have it divided here in waste from organic fractions, straw, firewood, wood chips, wood pellets, biogas, and then we have biodiesel, oil, and ethanol. So you can see a lot of fractions where the consumption of wood chips and wood pellets, that's the fractions where the development has been most increasing during the last 10, 15 years. So next slide, please. If you look at the district heating sector and the production here, and again look at the different kind of fuels we use there, you can see that 79% of all fuels, of all energy used in the district heating sector for producing district heating, 79% is more or less renewable energy. It's different kind of biomass, but it's also electricity, primarily from wind turbines and PV. And then the last 21%, that's based on coal, on oil, on natural gas, and the non-bio part of waste from households. So if we take the next slide, please. It shows again the development from 1998 and until 2023. You see in the middle the development of renewable energy in the district heating sector. And if you look at the consumption of coal, it has been dramatically reduced from 1998 until 2023. And at the same time, the consumption of biomass, it has increased. The biomass, that's a green one, and coal is the black one. So you can see a dramatic shift from coal to biomass in the Danish district heating sector. Next slide, please. A huge installation just for inspiration. That's a combined heat and power plant built back in 1990 and 2001. From the time where we focused on centralized district heating production. We have changed this philosophy today, like you also do in Ukraine, to have a more decentralized heat production. But this is a huge combined heat and power plant in Copenhagen, consists of 2 units, 2 storage tanks, 2 times 22,000 cubic meters, and a storage for wood pellets. And I will go more in details with these 2 units in the next slides, please. So next slide, please. The first unit, it was built in 1990 for 100% coal dust or oil firing. Back pressure mode, it could produce 330 megajoule per second heat and 215 megawatt power. But it can also operate in 100% condensating mode and produce 250 megawatt power. The total consumption of coal was here 85 tons per hour. And interesting was that the coal storage, it could cover 800,000 tons, and the annual heat consumption, it was 700,000 tons, meaning that we have storage facilities of fuel in this installation for more than 1 year's operation. It was converted back in 2016, so it could use 100% wood pellets for dust firing and 100% coal dust firing. The background for using wood pellets was that the boilers, they were constructed for coal dust firing, and the cheapest way to convert them to biomass, it was to rebuild them to use wood pellets instead of wood chips. And then we have separated dust mills for coal and for wood pellets. Yes, next slide, please. The Unit 2, built in 2001 for 100% natural gas firing and oil, and also straw in a small separate unit, or 75% wood pellets firing. They had the steam boiler and gas turbines, and total back pressure mode was 565 megajoule per second heat and 505 megawatt power. And in 100% condensing mode, 585 megawatt power. It was converted to 100% wood pellet firing 2016, so it could be fired 100% by wood pellets or 100% by natural gas. The wood pellets consumption for Unit 1 and Unit 2 is 7,000 tons per day. And from the picture you can see in this slide, it shows that the storage facility for wood pellets is 75,000 tons. That means we have 10, 11, 12 days storage capacity for the fuel now, compared to in the good old days where the unit used coal, where we had storage facilities for 1 year's operation. That means this is a challenge for the logistic when you make this shift from coal to wood pellets. Next slide, please. Smaller installations in Denmark. There's one here from a smaller district heating plant. They today cover 97% of the heat production comes from straw from the farmers in the neighborhood. The existing 7.5 million megawatt boiler from 2006, it was supplemented with a new boiler at the same size in 2014. So a district heating company, almost 100% based on straw firing. And the next one. Next slide, please. Yes, that's another district heating plant. It's founded many years ago, back in 1961. But what's interesting here is that they today have 3 different units. They have an oil-fired plant of 16.5 megawatt, then a wood chip-fired plant of 7.5 megawatt, a straw-fired plant from 2018 of almost 9 megawatt, and then an electrical boiler. So here you can see that instead of having a production capacity linked to one fuel, they can here use oil, they can use wood chips, they can use straw, and they can even use electricity. The electricity used here is not primary for producing district heating, but it's primary for delivering services to the power system. We can come back to that in another webinar. Yes, please, next one. Yeah, a combined heat and power plant, an industrial combined heat and power plant with 2 units, 7 and 8, built back in 1986 and 1998. Next one, please. It's built in connection with a big industry, the Yonkers industry, and they built this combined heat and power plant to utilize surplus materials from the from the factory. Next one, please. The factory, it's one of Europe's largest producers of solid wood flooring. We have some key figures here that they consume around 150,000 cubic meters of wood per year for producing this parquet flooring or plank flooring. Most of the raw material, it comes from Denmark, or a smaller part comes from Denmark, 35%, and the rest from the southern part of Sweden and from Germany and from Poland. So next one. When they produce these floorings, they get in the raw materials as logs. And when you look at such a log, they utilize between 20 and 25% for the floor production. The rest, between 75 and 80%, that's waste. So they have to get rid of this waste in the form of wood chips, in the form of sawdust, and the form of dust. So next slide, please. This biomass coming from the Junkers industry, it's 60,000 tons per year in the form of, as mentioned, wood chips, sawdust, and dust. And there's a contract between the factory and the owner of the combined heat and power plant going for 15 years, meaning that the district heating company owning the combined heat and power plant, they have an obligation to buy this raw material, and the factory, they have an obligation to sell all their waste biomass material to the district heating company. Next one, please. Furthermore, to the combined heat and power plant, they buy up to 100,000 tons of raw material from external suppliers in the form of wood chips or logs. There are 4 to 5 Danish suppliers of wood chip to the plant. It's transported to the plant by truck, and then there are 1 to 2 foreign suppliers, and it's transported by truck or it's shipped to the combined heat and power plant. And here we operate with contracts with a length between 3 months and up to 2 years. Next one, please. The construction of the Unit 8, it's relatively simple. It was built back in 1998, has an input capacity of 65 megawatt, and it's supplying electricity to the grid and process steam to the factory and to the production of district heating. And again, the steam production is based on wood chips, on sawdust, and dust, all taken from the Junkers industry. When the district heating company Vex took over the plant back in 2012, they reconstructed and converted the plant from a condensing mode to a back pressure mode plant, meaning that all surplus heat from this plant is utilized for district heating purposes. The next one, please. They have improved the plant after the taking over. So today the surplus heat from the cooling circuit from this lubricating oil, it's utilized in the district heating system. So 650 kilowatt is utilized, and the payback time for this investment, it was around 6 years. Then the ignition of the dust burners has been changed. So instead of using 300 liters of fuel oil for every start, they now use 3 kilos of wood pellets. And at last, a fuel gas condensating installation with a heat pump has been installed, giving the possibility to utilize around 13 megawatt more without burning more fuel, and the payback time for this is calculated to between 5 and 6 years. So a lot of possibilities to make the process even more efficient. So next slide, please. So what about bioenergy in Ukraine? A few slides. So if you jump to the next one, you have had a stable development of the production of biomass, and around 3 million tons per year now. It's calculated by the Bioenergy Association in Ukraine that your potential is around 23 million tons. That means between 6 and 7 times more than you use today. So next one, please. The topic, energy crops. Energy crops are plants that are grown specially for use as a fuel or for biofuel production. At the moment, you have 3 million hectares of unoccupied agricultural land, of which you only use 0.1%. So if you used a part of this area for energy crops, you could replace, if you used 1 million hectares, that means 1/3, you could replace half of all Ukrainian imported gas, the figures from 2018. So that's a potential if you utilize 1/3 of this area, which is not utilized today. And the benefit of using these energy crops is that it has a quick payback time if the policy is supporting this development and is effective. So next one, please. These figures, they are all from your, what do we call it, Ukrainian bio organization, and it shows the development where you are today, where you are expected to be in a few years, in 2000 and the 2030s, and in 2050. You can see that the amount of energy crops is expected to increase from almost nothing to 3 million tons per year when we reach 2050. So if you should follow this estimation of consumption of biofuels in Ukraine, you are busy. You are busy already this afternoon. There's no time for waiting. It's a hard job, but you have the potential. So I think that was the second last slide, and the last one should be a thank you. Yeah, good. So that was a quick introduction to how we do it in Denmark. When we talk about biomass, we use many different kind of types and fractions of biomass, and we use it in both huge installations, but also in small installations. When it's in small installations, it's often in a close cooperation between the district heating company, and it could be farmers or owners of forest. So it's possible to make long-term contracts. So thank you very much.
Thank you, Lars. Так, дякуємо Ларсу. Наступний спікер в нас також Ларс Юсцен. Це співзасновник компанії Юсцен Енергітехнік, яка є виробником саме по рішенням котлів на біомасі та когенерації на біомасі. І презентація буде технічною, тому так, я наразі передаю слово Ларсу Юсцену. Lars, are you with us?
Yeah, I am here, and first of all, I would like to thank everybody for wanting to listen to me. I can see we are now 15 minutes behind schedule, so I'm very happy that I asked for 45 minutes because I can do it in 30 minutes. So we will catch up. And Lesia, should I share the presentation on screen?
Yes, please.
Okay, I will do right away. And I will do it in the English version because I had the English version on my screen and I don't know what to say, but I should have sent you one also in Ukrainian version where parts of it are translated.
Just a second, Lars. Всі презентації ми потім викладемо на ресурс зовнішній і надішлемо лінк, тому у вас буде можливість їх всі отримати.
And now I'm also trying to find out how do I share on this Zoom thing. It must be this green arrow. Yes, it is. Am I sharing the screen now?
Yes.
So you can see, did I change slide here now?
Yes.
Okay, good. So thank you everybody for wanting to listen
Lars,
to me.
excuse me, one comment. We see now your presentation in demonstration mode. So like two slides nearby.
Yeah.
Could you switch it to the full screen
Yeah.
mode?
Is that better?
Super.
Yes.
Yeah. Okay. So thank you very much for letting me speak here today. I have a bunch of slides and thanks to you, Lars, because you have talked a lot about the big plans in Copenhagen city and all that. And I'm going to talk about a bit smaller scale biomass to power plants with also heat production. And a little bit about how we design systems here. So my presentation will be going a little bit into the technical side of things. And we are in cooperation with DBDH, Danish Board of District Heating, and Lars Gullev, and Danfoss and Kamstrup in the Mykolaiv project. And there we, together with Rambøll, have studied intensively the different agricultural biomass types that are available in Ukraine. And we have had some very positive surprises about their behavior in a boiler system. And the agenda is that first I will very, very shortly go through a few slides about our company. Then we will move to agricultural residues and their behavior. Then we will go to how that behavior of the agricultural residues influences the design of a combined heat and power plant. So that is it. And now it won't change slide. Why won't it change slide? Hang on. I do apologize. I think I have some kind of technical problem. Can you only see the front page?
We can see agenda, Lars. Now it's coming.
Okay.
Yes.
So about us is that we want to be a world-leading biomass boiler manufacturer, and we want to be it in a style of OEM, where we are working with partners around the world. So we always comply with relevant environmental legislation, not just in the short term, but also looking to the future. And if we think about Ukraine, everything that we are doing is complying with EU legislation, because we expect Ukraine to become an EU country. So the systems will be designed according to those needs. We do a lot of these speeches around the world, mostly in webinars. We are a member of World Bioenergy Association. We work in Australia, New Zealand, Asia, Central and South America, and all over Europe. So we think it's a very good idea to be member of these associations. And DBDH, Danish Board of District Heating, is not on this because I apparently haven't updated it yet. And then we only deal with biomass boilers. And then we have a little side business working with waste incineration also, but it is in a more limited scope. Our solutions, they cover hot water, saturated steam, superheated steam, which is relevant here, high pressure hot water, and a little bit of thermal oil systems also, but that is very rare. Inside one of our boiler systems, it looks like this. So one of the things that's unique with our systems is that we have a water-cooled grate system that is fully integrated with the heat transmission medium inside the boiler. And all walls and all grates are water-cooled to achieve a good life expectancy of the systems. And then if we have very wet fuel, we equip it with ceramic tiles instead of refractory lining. Visa X slide. I'm not showing the slides. I'm so sorry. It was just my... there we go. My colleague just came in and said, I'm not showing the slides. Can somebody confirm that it is a slide of a grate system now?
It's a boiler system component, water-cooled grate.
Yeah, fantastic. Thank you, Licia. I don't know what happened there. It's like I recently transferred to being a senior advisor, so forgive me for not being that good with computers. So if we have very moist fuel, we equip the inside of the grate with ceramic tiles, which means that the ramping times on a system, which is especially important for agricultural residues and CHP, is shorter compared to a refractory lined air-cooled grate system. And during our lifetime, we have developed different systems. When my parents started this company in 1958, there was nothing called biomass in reality. It was waste wood that was used in woodworking industry, and sometimes it was burned, and you made a little bit of heat on that. We started exporting in 1970, and as Lars Gullev's slide showed, we have now 80% coverage by renewable energy in Denmark. So we are, of course, mainly looking at the export markets. And now to our findings from our work in the Mykolaiv region. We have studied 14 different types of agricultural residues and energy crops, and looked at their characteristics and their behavior in boiler systems. So we have studied these 14, but I have taken 5 out here because they have characteristics that are different from each other. First of all, Pavlovnia and willow, we have found out that behaves a lot like wood chips in a boiler system. And I have highlighted with red the things I want to talk about here. So when we have wood chips, Pavlovnia and willow, you can have anything between 8% water and 60% water. In general, it's quite moist because we want it fresh. So normally we are looking at something like 35% moisture to 55% moisture. And this, apart from that, wood chips, Pavlovnia and willow, they are almost entirely carbon, hydrogen, and oxygen. There's only 1% other elements in this type of fuels. And that makes it very, very easy to handle, but I will get back to more on that. Then we have a significant type of fuel, and that is grain straw packed into bales, and that can be from wheat, it can be from barley, rape, rye, many things. Here we are looking at yellow straw from wheat, and there we have typically a water content 18 to 25% and an ash content of 2 to 8%, still quite low. But what is different here from wood is that we start to have a little bit more of challenging elements. So we have sulfur that is typically twice what it is of wood. That is important because you develop SO2 emissions. We have significantly higher nitrogen. It can be as high as 1.5%. Chlorine is 20 times more than wood, and potassium, which is a fertilizer, is typically also 20 times more than wood, and I will show later why that is important. And then we have something called the ash shrinking starting temperature. It's something that started to be measured since 2020, and that has a problematic behavior also. The physical properties of straw bales are that it's bales and then can be Heston mini big. Round bales in a medium-sized combustion plant, as we do, are problematic. We prefer bales to be square in order to shred them. Then a fuel that we looked at that we were a bit surprised about in a negative way, you could say, is the very high ash content on sunflower seed husks. It's 12 to 18% of the dry matter. Oxygen is low at 41.5%. Sulfur is similar to straw from wheat. Nitrogen is a bit higher. Chlorine is the same. And the potassium content is an amount I've never seen before in a test. 3% potassium, 3% fertilizer are going into these sunflower seed husk pellets. And the physical properties of this type of fuel is that it's quite sticky. Then on to buckwheat pellets, which was a nice surprise for us during these tests. And that is that they are slightly higher in sulfur and nitrogen than wood chips, Pavlonia and willow, which it makes it very, very suitable for highly efficient CHP plants. So that was the characteristics. My next slide then highlights what are the challenges here. We have already talked about the large range of water content to cover with a combustion system for the wood chips and similar fuels. For the straw bales and wheat, the sulfur will develop SO2 emission plus corrosion. There are two types of corrosion relevant for a CHP plant. The first type is what we call low temperature corrosion. That is when you have a moist atmosphere, which you have in the ignition zone of a biomass fuel boiler, then you can have wet flue gases that contains SO2 that has already combusted that will form droplets on the heating surfaces. So that's low temperature corrosion. When you do CHP, you have something called a superheater inside the boiler. And if you are above 360 degrees on that steel, SO2 becomes extremely corrosive. It's an exponential development of corrosion there. And I will state later how that influences the electrical efficiency. We have the NOx emissions that is part of EU legislation. We have the chlorine that develops hydrogen chloride, extremely corrosive. Dioxins, that is an emission that is not measured on biomass plants, except in France, but it is often relevant for local planning permissions. We have the potassium in the straw, which will form something called K2O, a molecule. If that is attached to a particle, then it will stick to the heating surfaces. And then finally, we have the ash melting behavior that you will have slacking, clinkering, and fouling in the boiler. Physical properties is that you need to debale the fuel into a uniform fuel. I would like to say a few sentences about that. If you are producing only heat, you can live with a fuel that is sometimes in big lumps and sometimes it's finely cut. But when you are doing CHP and you are operating to a turbine, you want to operate to the correct point for that turbine. And that makes it even more important that the debaling is uniform. Then we have the sunflower seed husks, large amount of ash. We showed on the previous slide that the oxygen was low. That's the same as saying that the volatility is low. There's a higher amount of fixed carbon typically in such a fuel. And other than that, it's basically the same as the straw bales. Then we have the buckwheat pellets that we have analyzed. And the only issues with that is that you will need to take care of the SO2 emission and the corrosion issues. And then you will need to also take care of the elevated NOx emissions. So the solutions to these challenges is that for the large range of water content to cover, it can mean that the temperature inside the combustion can vary by up to 400 degrees. So when you are having very moist fuel, you operate a preheating combustion air system. And when you have low fuel moisture, you operate a flue gas recirculation system to lower the temperature. To get into details how that is done is not covered here today. With the sunflower seed husks, you can see we have the ash problem there. And there we have developed Hardox chain conveyors to handle these large quantities of abrasive ash. Hardox is the same high-grade steel that are used in bulldozers and in the soil working industry. When you have the oxygen that is low, it gave this low volatility of it. So everything else being equal, we would increase the grade length inside the combustion chamber for those types of fuels. When it came to the sulfur content that is elevated for all these three types of agricultural residues, we would inject finely milled sodium bicarbonate before the filter. To avoid the corrosion, we would have high waterside temperatures, because if a steel plate is between 140 and 220 degrees, it's not subjected to low temperature, and it's not subjected to low temperature corrosion or high temperature corrosion. So that is kind of like the Goldilocks zone of steel plates when you are doing combustion. 140 degrees to 220 degrees is ideal. In the ignition zone and in the economizer, to protect against condensing sulfur dioxide, you can have stainless steel reinforcements. Turning to the nitrogen that is elevated for these, there's a complex design work all the time to inject urea or ammonia water to get the NO to react with the NH3 and then become atmospheric nitrogen and oxygen. So you are simply splitting up the NOx molecules again, and that is done either by a so-called SNCR system or an SCR system. The chlorine that developed dioxins, so it's important to have a good boiler design. You can clean upstream with this sodium bicarbonate and neutralize the hydrogen chlorine. And you have the T is for temperature, and you can also have the stainless steel reinforcements. So that's a bit of the same. The potassium is especially important when it comes to agricultural residues, because that is what causes fouling. Potassium, as I said, is a fertilizer. If that molecule called K2O is in connection with a fly ash particle, it sticks to the heating surfaces. So how you solve this is that you are ensuring that you have large radiation chambers lowering the flue gas temperature before it enters boiler tubes. It's more expensive that way, but it minimizes the fouling issues. And of course, you also clean with compressed air or with steam soot blowers and whatnot. And the ash shrinkage starting temperature is where the water-cooled grate system becomes really relevant. And the water-cooled grate system is also made with a high pressure drop over the grate. So you are ensuring that you have combustion air coming up in a distributed flow and not where the fuel is not placed on the grate. For the straw bales, we have a two-stage shredder system to ensure that it is very finely cutted before it enters the boiler, so we can operate to the specific point. And with sunflower seed pellets, we have these bespoke conveyors. I will try and speed up now. I will now go to the steam Rankine cycle to make CHP. You have the boiler system producing superheated steam that goes to a turbine of the back pressure type with extraction, where you are entering at very high temperature and very high pressure, and then at the outlet of that you take a part of that and put to the deaerator. The rest goes into the turbine condensing stage, and as you saw on Lars Gullev's presentation, there are two completely different electrical outputs based on whether you're condensing the steam in the turbine or not. If you're condensing, which is what you would typically do in the district heating, then you have wet steam on the backside of that condensing turbine. It will typically be 94% dryness, and that is what gives you an extra 6% of electrical efficiency. And it goes to a steam condenser, and that steam condenser is driven by or cooled by the heating surface of the district heating. And that's the whole philosophy about making combined heat and power in a steam Rankine cycle. I should say that an organic Rankine cycle is basically working the same way, but it is typically used for smaller systems. We have a water steam Molière diagram here, and there you can see the red line there where the back pressure turbine is taking enthalpy out of the steam, and typically you will have around 40 degrees overheating left when it exits the back pressure turbine. Then when it goes into the condensing stage, you are passing through the saturated steam line and going into the condensing phase of the steam, and that's really what generates the electricity. So it's a quite simple calculation I will show you in a moment. A steam turbine will have a so-called interlocking parameters, and that is what you see here. So when you see a steam turbine, it can operate to a certain steam quality, and then you would set an operation point, and that is always your aim, and that is why the physical properties of the fuel are so important, so you can adjust all parameters to hit that optimal operation set point. And in the superheater, there would be something called water injection, so you can flatten the curve, so you can always operate between 70 and 100% load to that point. And the heat balance basically looks something like this, where you can see the 17.8% there at the back pressure stage. That's electrical output compared to the thermal input. And then on the condensing stage, in total, you have 11.4, which gives a thermal to electrical conversion rate of 26.7. And that should not be confused with electrical efficiency. Electrical efficiency, you have to multiply by the thermal efficiency to arrive at that. So that would typically be about 10% lower than that. 10% would then mean it would be around 24%. And this is how a superheated steam boiler looks like on the inside. This is where we see through a 5 megawatt electric power plant that we have done in Riga. And this is during the construction of this plant. And we have several other CHP plants. This is a 2 megawatt plant in Slovakia. And we are working with different companies. We are an OEM, so we make the boiler, but we have strategic alliances with companies that can make the complete system. And that was basically it. Thank you very much. I hope I managed to catch up a little time here, and thank you for listening.
Yeah. Дякую, Ларс. Thank you, Lars. В нас наступний наш доповідач – це Кор Андреасен, фінансовий директор АЙФО в Україні, і це експортно-кредитний фонд Данії. Багато з вас, я сподіваюся, вже знають про діяльність цього фонду. І наразі Кор розкаже нам, як працює фінансування, тому що фінансування в секторі теплопостачання є також пріоритетним для фонду. Вони б хотіли мати більше проєктів, і ми, як Данська рада з питань теплопостачання, допомагаємо їм ці проєкти знайти, поєднати з данськими технологіями і налагодити цю співпрацю, цей контакт. Будь ласка, Кор. Kor, do you hear us?
Yes, I hear you. Sorry. And hopefully you can see me now.
Yes.
Excellent. Yes, and thank you for the invitation. My name is Kåre Andreasen. I work for the Danish Export and Investment Fund in Denmark, but has been stationed in Kiev for the last 2.5 years. And Lesia, is there simultaneously translation on this? Okay,
yes.
So I can just move ahead. Yes, the Danish Export Investment Fund, I have prepared a presentation. I hope I will be able to share it. I'm not always the best technician, but let me just try. Do you have my presentation, Lesia?
Yes, I do.
Maybe I can find out myself. I'm a grown man. I should be able to do that. Can you see my presentation now?
Yes, but you could please press the demonstration mode somewhere.
Yeah, and I hope it will still be there. Is it still here?
Yeah, it's still there. Yes, now it's full screen.
And does it move from slide to slide now?
It does.
Okay, excellent. Then I can move ahead. I will speak a little fast. I only have 15 minutes and time for a few questions. But you can have the presentation afterwards in PDF. And I also gave to Lesia our brochure and our expression of interest form in order for you if you want to participate or to cooperate with IFO. With these words, I will just get started. The purpose of IFO's Ukraine facility is to contribute to rebuilding of critical infrastructure and to develop the private sector and economy of Ukraine. Of course, energy is high on our agenda, and we have already done quite a lot of projects also within energy, but until now not within biomass. But we are very interested in doing these kind of transactions also in the future. But besides rebuilding Ukraine, we also will create jobs in Denmark, and this we do by demanding at least 30% Danish content in the projects that we're financing. This means if you have a project cost 100, we can provide the financing in different ways, but under the condition that at least 30 out of the 100 comes from Denmark. That can be services or that can be machinery and others. Our facility started with 140 million euros 2.5 years ago, but since then we have received more funding and we now have a total of 955 million euros. And plus that we actually have an extra 135 million euros to defense companies. But quite a lot, a total of 1 billion euros we have been assigned only to help rebuild Ukraine. And this is done on commercial and semi-commercial terms. We can provide loans to public buyers in Ukraine with up to 40% grants. This means if this is a public-owned utility that will buy a biomass, for example, or other equipment, we will ask for a guarantee from the city. We don't need a guarantee from the central bank or the Ministry of Finance, but we would need a guarantee from the city if it is a publicly owned company that will be the buyer of this equipment. But if it is, and we have the guarantee from the city, they only need to pay back 60% of the loan. Maybe a little more, because I think our grant will be between 30 and 35% and not the 40%. But this is due to, we want to use some of the grant to make the interest rate on the remaining part of the loan cheaper. So in total it will still be 40% grant, which is an excellent sales point towards Ukrainian cities and district heating companies. I can say we have done transactions now for 440 million euros in Ukraine in the last 2 years. A big part of that has been for the Teligulska windmill park, and here it was the tech that was the owner, and thereby it was a private loan to a private company without a grant. But we do also have made transactions and financing for 7 or maybe 8 cities now in Ukraine. And this we do normally in close cooperation with Ukregasbank or Ukreximbank. That means the banks, Ukrainian banks, will provide the loan and we will provide the grants. And this is quite how it works very well. But these are when there is a public buyer of the equipment, or if you yourself are a public buyer company, you will be able to buy these kind of projects if there's something Danish in, and you only have to pay 60 to 65% of the normal price. So quite a good deal. But we also do transactions with private companies, and here there's no grant, but still quite good financial possibilities. This is what we did, for example, with the tech and the huge windmill park of 380 million euros. But we have also done very small transactions down to 60,000 euros. We will do all kinds of size and amounts. We will not be much cheaper than the Ukrainian banks. We are a government organization and we are not here to outcompete the Ukrainian banking system. We are here to cooperate with them. So we will give the same commercial terms and price normally as the Ukrainian banks, but we can do it with a very long credit period, and you can start to wait to pay back until 2 years after the project has been completed. And since it is biomass, we can give a credit period for the buyer up to 22 years. So you will not find a 22 years loan anywhere else, at least not in the private banking sector. Yes, so these are the financial solutions, and for Danish exporters, we can also give Danish exporters insurance against breach of contract and if they are doing any investments in Ukraine. These are the financial solutions we have, and they are described more in detail in the brochure that you can receive afterwards. I have here the three things, or two of the things you will receive. We have the catalog, Financial Solutions in Ukraine, 4 pages. We also have it in Ukrainian, and it describes, among other things, what are the different ways that you can receive financing from IFO. It can be with a bank loan, where we guarantee the bank's risk. Can also be a loan directed from IFO, or it can be an exporter credit. If the Danish company wants to give a credit for 6 months for longer, we can guarantee the Danish exporter 100% against any losses. But all of these things, and also all the details about how our financing works, is in our described in this brochure. One of the things that is described is that private companies need to pay 15% up front, and then they can have a loan of the remaining 85%. But public buyers do not need to pay anything up front. The brochure also describes that if IFO is involved giving the loan or guaranteeing a bank loan, then you need to use at least minimum of 30% from Denmark. But the rest of the loan you can use to import from other countries, and you can also use part of the loan for the local cost, meaning buying equipment and services from Ukrainian companies, including construction, for example. And you can also include your financial costs, meaning the interest rates you can actually borrow also. So the loan can be used to every cost that is in your project, everything, all import and so on. These are some of the things described in our brochure you see to your left. In the top we have an exporter catalog. We can send that also to you. That is description of 450 Danish companies that we can work together with. And that is just for inspiration, because we can work with many other companies also from Denmark. Just ask and we will look at them. We have the exporter catalog both in English and Ukrainian. If you are a Danish company listening now and wondering if you are in the catalog, please contact me and I will make sure you can be part of the catalog as soon as we have found out you're not a criminal or anything like that. In the bottom, you see our expression of interest. This is how we start the cooperation. We don't need a lot of paperwork. We just need you to fill out those 3 pages with the basic information, send it to me. And then every month we meet in IFO's screening committee and decide which projects to continue working with. The expression of interest is free of cost and there's no obligation. It's simply a good working paper for us to get started and also to allocate a project manager from our side. These are the main documents you would need from our side. Our principle is we cover 100% for the banks or the exporters having any risk. We do small and big transactions, as I said, 60,000 euros or 380 million euros, both are good for us. And we also work with big and small buyers and exporters, and we do all different kind of financial solutions that we also do in other countries. We do we have been involved in 8 sectors, but I think 1/3 of our total involvement in the last 2 years has been in the energy sector. The other 1/3 has been in the agricultural sector and food processing. So this is one of the reasons we have big hope for biomass projects in the future. And of course we can see we are already looking at different projects already, and we have also involved DBDH in some of this and leisure. The requirements is at least 30% comes from Denmark, and that if it's a private borrower, then they need to have an equity that is 3 times higher than the loan amount. So if you need a loan for 3 million euros, you need an equity of 9 million euros. Else, we look at those criteria every month in the screening committee when we are presented for a range of projects. It needs to help rebuild Ukraine. US, of course, will here. We need it to be quite mature, meaning that we need to be so developed the project that we can expect to pay out the loan and the financing within 6 months after you come to us. We cannot reserve the money for 1 or 2 years. We need to get moving. So the maturity has been this kind of feasibility study, make sure, and approvals and so on, make sure you're pretty far in the development. We can still do the dialogue before, but we cannot commit us before we can see these things are in place. Another criteria is the 30% Danish interest. And the remaining you can put in parentheses. They're not that important actually. The financing here, I will not go through them all. I have quite short time left, but we can give direct loans. What is important here is a mistake. I said it's only put 40% grant element on our own direct loan from IFU, but we do give 40% up to 40% grants in all kind of financing. We have also been doing it when we have been doing leasing projects in Ukraine. They only had to pay back 60% of the leasing amount. We have done it if it's a bank loan. They only need to pay back 60% of the bank loan. But we give loan, banks give loan, the Danish exporter gives a loan, we do a leasing, we can do short and long term, and so on. So we do all these different kind of financial solutions, and we will tailor-made it to what you need and what your customer and exporter, what is best for them. We do IFU guarantees to Danish exporters. I will not go through that here. They can contact me if they need a guarantee, if they're afraid of bombing of their investments in Ukraine, or they're afraid of breach of contract. We can also, if they have to issue bond guarantees, we can guarantee them there also. Risk period, it has to be a minimum of 6 months, normally a minimum of 2 years. But on the top level, we can do on normal projects, normal export up to 15 years credit period, and within renewable energy up to 22 years credit period. This will depend a little both what the borrower wants, but also the size of the risk. If it's only 1 million euro, we will not give 22 years credit period. There we would normally give maybe 3 to 5 years at the most. But for larger projects, 15, 20 million euros, we would normally be able to give 15 years credit period or even longer. This is just describes that for private companies, they need to pay 15% up front. There is a question sometimes, I talk about 30% comes from Denmark, but what is this coming from Denmark? How is that described? That is described right here, and you will receive the paintings, but the main thing is there needs to be some added value in Denmark. Either production directly in Denmark or production at a Danish subsidiary in somewhere else in another country, but we can also include service contracts and others. It's quite broad what we describe as Danish content. But please, let's start out with that in the dialogue. Is there enough Danish? And do we consider it as Danish? If it's something a company in Denmark has just imported and reselling in another country, in Ukraine, that is not what we call Danish content. It's fine if they buy 2 components and put them together, make value added, then it is Danish content. Timeline and process. This is one of my last slides, and it's very bad because it looks like it's a long process and timeline. But what it is actually is it's only the first point that is interesting. contact IFO or contact me, and we will take the dialogue from there. The next step would be that you fill out, or your customer or bank fill out this expression of interest, and then we will present it for our screening committee. And that is done 12 times a year. So we are moving forward, and our credit committee meets every second week if there's any transactions, so they will do it immediately. Normally, after it's approved by the screening committee, it will take between 2 and 8 months to get the loan paid out, depending mostly on the paperwork, especially when we receive the needed information. But we do move very fast, and has done 24 transactions in the last 2 years, and spent 440 million euros. And I'm only, my CEO said I can make mistakes, I can lose money. That is what to be expected under these circumstances. But I cannot be passive, I cannot sit on the money. They need to come out working. And this is why I try in all ways I can. One of the reasons why I try so much is trying to find companies, exporters and buyers that wants to help us rebuild Ukraine. The expression of interest, I will not go through it, but just to show you that it's not too much we ask for. We just need to know who is applying for this, and what are they applying for, financing information, is it a loan or leasing, and how much? And then what is the project? The bottom, how much comes from Denmark, how much comes from other cities, how much is expected for taxes and so on. This is not the final, this is not an application, just an overview so we can get an maybe not exact idea, but some idea of how much is we are financing. Second page, project information, where is it located, what is it? And also below that, project development stage. Has there been made a feasibility study, and does it need to have? Do you have the approvals? If it's a public buyer, has it already been discussed in City Council? We need to know these things, so we will not sit and wait for 1 hour, for 1 year or anything. But fill it out, send it to me, and I will return to you if I need extra information. The last page is buyer information. This is only to be filled out for private companies, not for public buyers. We do have the financial information we need for the cities and municipalities or ministries in Ukraine. Highlights, I will not repeat myself. I already repeated myself a couple of times. So thank you for your time, and I will stop sharing here. And please let me know if you have any questions now, or please feel free to contact me afterwards.
Thank you, Core, and I think we have a question. Шановні учасники, я думаю, що зараз є в нас час для коротеньких питань. Тому я зачитаю перше питання для Кора із IFO. Скажіть, будь ласка, ні, це не це. Яким чином, враховуючи українське законодавство, можна забезпечити закупівлю не менше 30% саме данського обладнання? Or did you hear the question?
Sorry, I didn't understand. Can you please repeat? I can't hear anything, Leslie.
Core, do you hear us?
Yeah, I hear you.
So maybe I should ask in English. Do you hear me now?
Yes, please ask me in English.
Yes, so taking into consideration the Ukrainian legislation, how we can make this possible of procurement of 30% specifically of Danish equipment in the project?
Yes, excellent question, and one of our biggest obstacles in order to do transactions and projects in Ukraine. It is, as we understand, not allowed to say directly that there needs, in the procurement, that there needs to be 30% Danish content. However, we do have seen where the procurement has been between developers, and for those developers, it has been described that they need different kind of Danish content. So that is one of the ways to do it. A second way has been to, in the normal procurement process, to describe very precisely what kind of quality and other technical specifications they need, because in this way you can kind of tailor-make the procurement process to a Danish content, or at least to high quality. This is in order for you not to do a tender process where it will be the lowest price and you will get some crap from China or somewhere else. A third way could be that the project is made as leasing arrangement, and here the leasing will be between the financial companies that provide the leasing and not be between the Danish exporters. So there are a range of different ways, but it is uphill. We hope by the end of the year we will have a framework agreement whereby it will be that automatically it can only be Danish suppliers or companies with 30% coming from Denmark that can bid on it. But it seems to take quite a long time also from the Danish bureaucracy before we have this framework agreement in place. Until then, we will do it slowly, but we have done it with 7 different cities. And if we go into dialogue, first of all, I will try to involve Bank or Bank as soon as possible and to learn from their experiences and their advice. And also, we have projects already in Mykolaiv and Bucha, Venezia, and a range of other cities where they have been through this process, and they can tell you more detailed how to do it. The problem is the tender procedure in Ukraine is quite difficult for IFO to understand, especially since it's different from place to place, from city to city, from sector to sector. There are some changes that we are not aware of always.
Thank you, Ko. I will take other questions now.
Yes.
Зараз наступні питання, і в нас було питання від Оксана. Ви надсилали в чат перелік питань, да? Я думаю, може ви їх озвучите, тому що вони і англійською, і чи може я їх тоді озвучу? Тут перше питання, що я бачу, питання до Ларса Гудева. Скажіть, будь ласка, установки, про які ви розповідали, працюють тільки в опалювальний період?
Did you ask me again?
No, it's a question for Lars Gulev.
Okay, Lise, but then you please repeat it in English, because I do not have a translation to English.
Okay, because you can actually choose the translation to English, but to keep it short, please explain the equipment and the plants on biomass about which you have been talking. Do they operate only in the heating season?
No, all district heating companies in Denmark, they operate 24/7, 360 days a year. They do that because they also supply the district heating end users with hot tap water. So they are operating all year round.
Thank you, Lars. But maybe then we have few other questions which you can answer. Cooling. It was built new network system for this service. How does it work on construction level, probably? If you can open the chat, Lars.
Sorry, who did you ask this for, Lesjan?
That's also for Lars Gulev, the questions.
Yeah, I saw, Lars, your presentation, and you mentioned about cooling services within district heating at one of central district. And it's interesting, it was built new network system, or you use this, or it was use the same pipes, etc. How it works just now.
Yeah.
And my next question, the second, related to energy security. Do you have special measures related to energy security, especially for Ukraine? Just now, it's so important to understand what type of energy security should be on the level of district heating, and what about big CHP or big heating plant? Just now, there is such policy in Ukraine that we should decentralize big heat generation plan and to focus more on smaller district heat plants. Again, taking in account our energy security issue. Thanks.
Yes, good. Thank you very much. When I talked about selling services, it's today normal for Danish district heating companies that they invest in electrical boilers, not primarily for producing heat based on electricity, but to offer services to the power grid by operating these electrical boilers when there's no balance between the actual power production and the power demand. And the background for that is that a larger amount of the power production in Denmark today is based on wind turbines and solar, which means that the driver for the electricity production, that's not the actual electricity demand, but it's how much wind and how much sun do we have at the moment. So that's a new business opportunity for district heating companies to sell services, to keep the frequency in the power system, to sell these services to the power system. So that's what I meant when I mentioned this selling services. About security of supply, during the past we have built large combined heat and power plants, centralized power plants, and that was the example I showed where we have converted one of these large centralized combined heat and power plants from fossil fuels to wood pellets. We see a transition in the district heating sector where we move away from centralized production and more focus on decentralized heat production, which also make it possible to utilize local energy resources in the district heating systems. So a transformation from centralized production to decentralized production. And it's always a benefit of that is that it will increase the security of supply. When we look at the security of fuel supply to the district heating sector, we focus on different kind of fuels. The large combined heat and power plant, you can see it could be fueled by 100% natural gas or oil and 100% wood pellets. Many district heating, smaller district heating companies, They have different kind of technologies in their production capacity, so they can use natural gas, they can use wood pellets, they can use heat pumps, they can use electrical boilers. So also here split up the production capacity in different technologies, so you can use different kind of fuels. So that's what we do in Denmark, and it's also the same transformation you have started in Ukraine, and I can only recommend that you continue with that.
Thank you, Lars. Чи є в нас ще запитання? Я так бачу, що ні. Оксана висилає в чат інформацію по наступному вебінару, по наступному заходу 11 березня в такий самий час. Я також думаю, що у Годомерів надійшло це запрошення на скриньку. Ми будемо можливість зареєструватися. І сподіваюся, що матеріал, який ви отримали сьогодні, цікавий, корисний і допоможе вам в плануванні, проектуванні та реалізації ваших проєктів. Зі свого боку, вдячна за вашу участь. Дякую також Угоді мерів за співпрацю. І ми розійшлимо презентації, розійшлимо матеріали найближчим часом. І будемо раді бачити вас на наступних заходах. Дякую.
Дякую.
Дякую всім. До побачення.
Дякуємо перекладачам.
Okay.